Imagine soaring 60,000 feet above the Earth, where NASA is launching an audacious mission to track down the precious minerals fueling our everyday gadgets, electric vehicles, and the clean energy revolution. It's a high-tech hunt that's not just about science, it's about securing the future of technology as we know it. But here's where it gets controversial. What if this quest pits national security against environmental protection? Stick around, because the details might just challenge what you think you know about mining in the 21st century. At the heart of this endeavor is NASA's cutting-edge sensor, known as a VIRUS, 5, or the Airborne Visible/Infrared Imaging Spectrometer, 5. This innovative device builds on technology pioneered by NASA's Jet Propulsion Laboratory, JPL, back in the 1970s, a place renowned for its groundbreaking work in space exploration, as detailed on space.com. Roughly the size of a standard microwave oven, a VIRUS 5 is cleverly installed in the nose cone of one of NASA's ER-2 high-altitude research airplanes, which fly at extreme heights to capture data without interference. The sensor's story began in 1986, and JPL has continuously refined it over the decades to enhance its accuracy and capabilities, turning it into a powerhouse for remote sensing. This sensor is a key player in an ongoing initiative called GEMx. One fascinating reason deserts make such perfect hunting grounds for mineral detection is their sparse vegetation. Without many trees to block the view, scientists can get a clear, unobstructed look at the land below. Since kicking off in 2023, a collaborative team has already surveyed an impressive 366,000 square miles, that's about 950,000 square kilometers, across the vast American West, mapping out potential mineral hotspots with unprecedented detail. So, how does a VIRUS 5 actually spot these hidden riches? Many critical minerals possess distinctive chemical compositions that interact with light in unique ways. When sunlight hits the Earth's surface, these minerals reflect specific wavelengths of light, creating what scientists call spectral fingerprints. Think of it like a barcode scan. A VIRUS 5 detects these reflections from high above, using advanced spectroscopy, a technique that analyzes how substances absorb or emit light to identify minerals that might otherwise remain buried and unseen. For beginners diving into this, spectroscopy is basically like giving each mineral its own personal ID code based on light patterns, making it easier to pinpoint valuable resources without digging everywhere. The U.S. Geological Survey, USGS, defines critical minerals as those with major implications for America's economic stability and national security. These include essentials like aluminum, lithium, zinc, graphite, tungsten, and titanium, materials indispensable for building semiconductors, solar panels, and electric vehicle batteries. For example, lithium is a star player in EV batteries, powering the shift towards sustainable transportation, while graphite is key for the electrodes that make those batteries efficient. And this is the part most people miss. These minerals aren't just commodities. They're the building blocks of our tech-driven lives, from the phone in your pocket to the solar farm powering your neighborhood. In a bold move announced in March 2025, the White House issued an executive order aimed at ramping up domestic production of these minerals to the maximum possible extent. The order highlights a pressing concern. America's reliance on imports from foreign nations poses a serious threat to our economic and national security. But here's the twist. Critics might argue that rushing into more mining could harm fragile desert ecosystems or local communities. Is this a necessary step for independence, or are we overlooking the environmental costs? It's a debate worth having, especially as global tensions rise. Beyond the earthbound hunt, spectrometers like a VIRUS 5 have a stellar history in space exploration. Over the years, JPL-designed versions have equipped spacecraft, helping scientists unlock secrets about distant worlds such as Mars, Mercury, and Pluto. For instance, one such instrument is currently journeying to Europa, Jupiter's icy moon with a subsurface ocean, to scan for chemical signs that could support life. As a JPL spokesperson explained in a recent statement from JPL's website, it's like a cosmic detective searching for the ingredients of extraterrestrial biology. Dana Chadwick, an Earth system scientist at JPL, sees even broader horizons for a virus. 5. The breadth of different questions you can take on with this technology is really exciting, from land management to snowpack water resources to wildfire risk, she shared. Critical minerals are just the beginning for a virus. 5. In other words, this sensor could revolutionize how we monitor water supplies in snowy regions or predict fire dangers, turning mineral mapping into a tool for environmental stewardship. Julian Dossett is a freelance writer based in Santa Fe, New Mexico, specializing in the rocket industry and space exploration. He also pens travel stories for New Mexico magazine, where his work earned IRMA awards in 2022 and 2024. With a background as a staff writer at CNET and a BA in philosophy from Texas State University in 2011, he brings a unique blend of science and storytelling to his pieces. Fun fact, he collects a vast array of 1960s sci-fi pulp magazines, a nod to the imaginative roots of space exploration. What are your thoughts on balancing mineral independence with ecological concerns? Do you see NASA's high-altitude tech as a game-changer for sustainability, or is it just another way to exploit natural resources? And speaking of controversy, should we view foreign reliance as a hostile threat, or is there room for international cooperation? Share your opinions in the comments below. We'd love to hear differing viewpoints. Please confirm your public display name before commenting. If you're logged in and seeing this, try logging out and back in. You'll be prompted to enter your display name.